This is homework set 40, Systems of Linear Equations in Two Variables. Question 1 asks us to solve this system of equations by graphing. So I'm going to graph both these equations. I think what I'm going to do here is I'm going to call this one equation 1. This one here I'll call equation 2, and I'll graph them in different colors. So in equation 1, look what we have. I'm going to use this slope-intercept form, right? I'm looking at this form right here. Y equals mx plus b. Now in this case, in our case here, m is 0. No. M is negative 5/4, and b is 0. So this line here crosses the y-axis right at 0. So I can put a point there. So I'll put a point here at 0. And then I can get another point by using the slope. Now the slope is negative 5/4. I'll associate the negative with the top. So negative 5/4. The bottom is the horizontal change, so it's positive 4/4. And the top, negative 5, down 5. So over 4, down 5. I'll put another point right there, over 4, down 5. And let's pass a line through these 2 points. So as best you can, draw a line through those 2 points. I'll put arrows on it to indicate that it keeps going. Now in line 2, this crosses at 1, so I'm going to put a point here at 1, right there. And the slope here, right, the slope, well, there it is, negative 3/2. All right, so this says start at that point that you know, go to the right 2, down 3. So to the right 2, 1, 2, 3, puts me here. All right, so I'll put a point there. Down 3. 1, 2, 3. I think that was it right there. Okay, now as best you can, pass a line through those points. So I'll draw that line as best I can. Oh, look at that. I think I did that pretty close. So where do they intersect? Where they intersect, that's the x and y value that solves this system of equations. It sure looks to me like they are intersecting right there. All right, which is our point to the right 4, down 5. So I'm going to claim now that x is equal to 4, y is equal to negative 5, or we could write it as an ordered pair as 4 and negative 5. Question 2 asks us to solve this system of equations by graphing. So I think I'm going to start here by letting the first, I'm going to name them. First equation, top equation will be equation 1. Second equation, I'll name equation 2. Now equation 1, I've got the variables here on one side and the constant on the other. And these coefficients, negative 1 and 1, both divide evenly into 1. So I'm going to use the intercept method. So for equation 1, I'm going to make a little table here. I'll choose x to be 0. I'll put a little star there because that's the one I'm choosing. Now you can just do this in your head. Just run over here to the equation. If x is 0, what do you get for y, right? So if x is 0, that's gone, and I get y equals 1. Right, so there's a point, 0, 1. And now let y equal 0. I'll put a star there. That's the one I'm choosing. And if y is 0, come over to the equation. If y is 0, I get negative x equals 1. So x must be negative 1. And there's another point. Now let's plot those 2 points. So 0 and 1 right here, and negative 1 and 0 right here. Now let's pass a line through those 2 points as best we can. I've got my straight edge. That looks pretty good. Now for line 2, I notice it's in slope-intercept form, so y equals 1x, right? 1x minus 4. So in line 2, oh, that's not showing up too well, is it? All right, so in line 2, the slope here is 1, and b is negative 4. So I'll plot those points. So it passes through the y-axis at negative 4 and slope 1. So over 1, up 1, over 1, up 1, over 1, up 1. And before I go any further, it's starting to look like these lines are parallel. So here's what I'm going to do. What is the slope here. All right, the slope in line 2 is 1. All right, so the slope here is 1. What about line 2? Here's what line 1. Negative x plus y equals 1. So solve for y. Y equals, all right, I'm going to add that to each side, x plus 1. So now this is y equals 1x plus 1. Here, the slope is also 1. So the slope of line 1 is equal to the slope of line 2. So that implies that line 1, that implies that line 1 is parallel to line 2. So no solution. Or I think the textbook wants us to write, how many points of intersection are there? There are 0 points of intersection, no solutions. Question 3, again, we're supposed to solve this system by graphing. Now, I've got two equations here. I'm going to call the top one equation 1 and the bottom one equation 2. Now, something looks curious to me here. Like, look at this top one. You see, I've got a -2, a -2, and a 4. All right, if I divide this by 2, I'm just going to do that to see what happens here. So here's what I'm doing. I'm going to take equation 1. I'm going to divide by 2. It would look like this. -x minus y equals 2. Okay, do you see it? All I do is I divided everything by 2. -2 divided by 2 is -1, -1, and 2. Now, that looks to me a little bit like this one here. What if we were to do this? Solve for y. All right, so if I solve for y, I'll get, all right, I'm going to add that x, so I'll get -y is equal to positive x plus 2, and then multiply by -1, I'll get y equals -x minus 2, which turns out to be exactly equation 2. All right, so what I'm saying here is that it looks like equation 1 is the same as equation 2. So if I graph these, they're going to just be the same line. So I'm going to say there are infinitely many solutions. Same line, that means these lines are coincident, meaning they intersect in infinitely many places. So what you say, there's infinitely many solutions to this system. Question 4, let's solve this using the addition method. Now I'm going to label these. Here's equation 1, here's equation 2. And I can see that if you just added these two, wouldn't the y's just go out? So let's do that. So here's the plan. I'm going to take equation 1 and add equation 2. It'll look like this. Just go ahead and do it. It'll look like this. 6x, the y's are gone, equals -6. You can solve that. Divide, right? Divide. I'll get x equals -1. All right, there's the x. Now I'm going to take this x and substitute it back into one of these equations. Say I put this into equation 1. All right, if I put that into equation 1, I'll get this. 3 times -1 plus y equals -4. Or how about -3 plus y equals -4. And then add 3, I'll get y equals, what do I get here? -4 plus 3 is -1. All right, so here's the solution. X is equal to -1. Y is also equal to -1. Or I could write it as an ordered pair, like -1, -1. Either way. Question 5, we're going to again use the addition method to solve this system. Now here's what I noticed. What I'm trying to do is add two equations together so that I can eliminate one of these variables. Now, what do you see this? If you were to multiply this top equation by 3, you get +9, and then -9. You add those, they'll go out. So here is my plan. I'm going to label the top equation as equation 1. The bottom one is equation 2. And my plan is this. I'm going to take 3 times equation 1, add it to equation 2. Now here's what that's going to look like. I'm just going to go ahead and do it. Multiply everything in equation 1 by 3. Right? So just multiply through here by 3. I'll get 3x plus 9y equals 6. And then equation 2 is 2x minus 9y equals 4. Add them together. I'll get 5x, the y's are gone, equals 10. Oh, we got that one. Divide by 5, we'll get x equals 2. All right, so I got 2 for x. Now, take that x value and put it back into one of these equations. It doesn't matter which one. I think I'll just put it back into the first one. All right, so doing so, I will get 2 plus 3y is equal to 2. All right, let's subtract 2. So I'll get 3y equals 0. So y must be 0. All right, so if I now claim that x is equal to 2, y is equal to 0, or write them as an ordered pair, 2, 0. And that is a look at the first 5 questions in our homework set 40.